In this video, I'll be covering the numerical problems based on lens formula. So first, let us deal with sign convention. So keep in mind, anything we deal with sign convention, think of it like a number line. If the middle is 0, then we refer the left side as negative and the right side as positive. The sign convention works for both convex and concave. The object will always be on the left side. So let's say the distance of the object from the lens is u. Since u is always on the left side, the sign of u will always be negative. There are two types of images. You can have virtual image or you can have real image. So in both the cases, the distance will be considered as v. Whether it is virtual image or real image, we will call it as v. So in case if we get a virtual image and it is on the left side, the sign of v will be negative. Whereas if it is a real image, it is on the right side of the lens. So in this case, the sign of the real image will be positive. Next, we will deal with focal length. If it is convex, since it is on the right side of the lens, it will be positive. And if it is concave, since it is on the left side of the lens, it will be negative. So now let's revise the concept. So what is the sign of u? So u is always negative. What is the sign of v? So if it is a virtual image, it is negative. If it is a real image, positive. What is the sign of focal length? So if it is a convex lens, it is positive. If it is a concave lens, it is negative. So the lens formula is as follows. 1 by u minus 1 by v is equal to 1 by f. Where u is the distance of the object from the lens, v is the distance of the image from the lens, and f is the focal length. So the formula for magnification is m is equal to v by u. There is one thing you have to remember over here is, once you calculate the value of m, you will get a sign and a number. Both have different meanings. If the sign is negative, then it's a real image. If the sign is positive, then it's a virtual image. Next, you can look at the number. If the number is more than 1, then it is magnified. And if the number is less than 1, it is diminished. Also remember the following points. A convex lens will always form a real and inverted image, whereas a concave lens will always form a virtual and diminished image. But there is an exception when it comes to convex lens. That is when the object is placed between f1 and lens. So in that case, you will get a virtual and magnified image. So keep in mind, if it is a virtual and diminished image, it is concave. If it is a virtual and magnified image, it is convex. Pause the video and try to write the given statement along with the correct sign. Once you are done, you can resume the video. So the first one, the distance of the object from the lens is 12 cm. So since it is object, u will be always negative, so minus 12 cm. Second question, the distance of the inverted image from the lens is 14 cm. So again, here it is mentioned inverted image. So since it is inverted, obviously it is real and it's on the right side. So v is equal to plus 14 cm. The focal length of a convex lens is 8 cm. So since it is mentioned convex lens, f is equal to plus 8 cm. The focal length of a concave lens is 12 cm. Again, since it is concave and it's on the left side, so minus 12 cm. The distance of the virtual image is 8 cm. So since it is mentioned virtual image, it is on the left side, so v is equal to minus 8 cm. In the last question, a lens forms an image on a screen which is 12 cm from the lens. So since the image is formed on a screen, it is a real image. Therefore, v is equal to plus 12 cm. So let's try some questions based on lens formula. An object is placed at a distance of 24 cm. Since it is object, u is equal to minus 24 cm. The convex lens has a focal length of 8 cm. So since it is convex lens, f is equal to plus 8 cm. First question, what is the nature of the image? A convex lens always forms a real and magnified image. So if you take this is the lens, focal length is over here 8 cm. Focal length is at 8 cm. So obviously 2f will be at 16 cm. And the image is somewhere around here at 24 cm. A virtual image is formed only when the object is between the focal length and the lens. So in this case, it is away from the focal length, so it will form. So the nature of the image will be real and inverted. Now B, you have to find the distance of the image. That is v, we have to find v. So we can use lens formula 1 by v minus 1 by u is equal to 1 by f. So 1 by v minus 1 by minus 24 is equal to 1 by 8. So 1 by v minus minus will become plus 1 by 24 equal to 1 by 8. So 1 by V is equal to 1 by 8 minus 1 by 24. So 1 by V is equal to, let's take LCM. So 24. So 8 3s are 24. 24 1s are. So 1 by V is equal to 2 by 24. 1 by V is equal to 1 by 12. So V is equal to 12 centimeter. So we have created a distance of the image, which is 12 centimeter. Now, in order to find magnification, M is equal to V by U. V is 12 and U is minus 24, which is equal to minus 1 by 2. Like I have informed you, minus basically means it is a real image. So only look at the number. In this case, the image is diminished. Try to solve this question on your own. Once you're done, you can resume the video. So here in this case, they've given a convex lens of focal length 10 centimeter. So F is equal to plus 10 centimeter. Is placed at a distance of 60 centimeter from the screen. So what exactly is this? So since screen is mentioned, obviously it means it is the image distance. So image is on the right side. Since the image is formed on a screen, so in this case it will be plus 60 centimeter. So the question is how far the object should be placed to obtain a real image on the screen. So we need to find U. So we can use lens formula. 1 by V minus 1 by U is equal to 1 by F. So 1 by V is 60 minus 1 by U is equal to 1 by 10. Let's shift. So 1 by 10 minus 1 by 60. Take LCM. So 60 in this case. 10 6 1 minus 1 by 2 is equal to 5 by 60. Simplifying it, 5 1s are, 5 12s are. So you'll get U is equal to minus 12 centimeter. So the object should be placed 12 centimeter from the lens. Let's try one more question over here. So in this question, they've given the height of the object is 20 centimeter. So they've given the height of the object, which is 20 centimeter, is placed in front of a lens at a distance of 50 centimeter. So the object is placed. So the object is placed at a distance of 50 centimeter. So U is equal to minus 50 centimeter. So in this, they have given virtual and diminished images formed at a distance of 15 centimeter. So if it is virtual, obviously it is on the left side. So V is equal to minus 15 centimeter. And also what type of lens it is, if it is a virtual and diminished image. So if it's a virtual and diminished image, it is a concave lens. So let's use lens formula to find the focal length. So 1 by V minus 1 by U is equal to 1 by F. So 1 by minus 15 minus 1 by 50 minus 50 is equal to 1 by F. Minus minus we can multiply, which will become 1 by 50 equal to 1 by F. So let's take LCM of the denominators. So LCM will be 150. So 15, 10s are minus 10 plus 3 is equal to 1 by F. So therefore minus 7 by 150 is equal to 1 by F. Taking reciprocal, 150 by 7. So the focal length will be around minus 21.43 centimeter. If you want to practice more questions, I have uploaded a PDF. You can find it below in the description.